Check. This. This one, two. Hmm? Check. Testing one, two. Hey, hey, hey. Sound check. Test one, two. Okay. test, check. Check, test, check. Hello. हाँ. Check. Hello. Hello. Check. 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 हाँ. हेलो. हेलो. हाँ, स्टेज में हूँ. हेलो. 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 कना वर्दा. हेलो. चेक. 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 हेलो. हेलो. चेक. हेलो. 1 2 3 4. चेक. हेलो. शीतल जी. शीतल. शीतल जी. सुन रहे हैं क्या? आवाज़ सुन रहा है? ठीक. ठीक है अभी. हाँ ठीक है जी. ओके. नहीं मिनट. एक मिनट. एक मिनट. एक मिनट. हेलो. हेलो. ओके. ठीक है. बाय. हाँ 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 हाँ. ओके. ठीक है. ओके. ठीक।
Ladies and gentlemen, a very good evening to all of you. We are delighted to begin one of the most awaited segments of the day, the Grand Awards Ceremony. This ceremony celebrates excellence, innovation, and outstanding contribution across various domains of engineering and technology. We extend our heartfelt congratulations in advance to all the awardees. The awards were not conferred during the year 2023 and 2024 due to the government directives applicable across all the government department, autonomous bodies and sectors, and were reinstituted this year after attaining of functional and financial autonomy by the Academy from April 1, 2025 onwards. As we commence this prestigious celebration of Grand Award Ceremony, it is now my honor to invite Mr. J.D. Patil, President INAE, Professor Shivaji Chakravarti, Vice President Fellowship and Awards, Mr. T. Suvarna Raju, Vice President Resource Generation, Corporation Communications and Membership, on the dais please. I also request Lieutenant Colonel Shobit Rai, Officiating Executive Director INAE, to please come to the dais. Thank you. To begin this prestigious ceremony, may I invite Mr. J.D. Patil, President INAE, to kindly deliver the opening remarks.
Good evening, ladies and gentlemen. Yesterday we heard the 7 luminaries who spoke right from this dais. This is part of what we call the different types of awards that INAE used to grant, had been under suspension for some period, and the 155th Governing Council meeting in June of 2025 decided to reinstate all the awards that we used to do till about 2021. As obviously lots of actions followed as part of this Governing Council decision, and each and every of those awards, which I'll just read out the details, they were kept on hold. Last awards we had distributed, and that were cleared in October 2022. So it was precisely 3 years we sort of did not do any award distribution or award ceremony. Why it was felt extremely important by the Governing Council was for a simple reason that there's amazing work that happens in engineering, and when we have some of that, it needs to be showcased. It needs to be showcased for multiple purposes. One is that the government takes note that this kind of a thing really happened. All of our fellowship takes note of what has happened. It also inspires the next generations to keep doing better and better. So as a part of this awards, we decided we'll reinstate the Lifetime Contribution Award in Engineering, and this was yesterday we heard 2 luminaries who were being awarded or who will be awarded today. Yesterday they spoke on and they presented in terms of their work during their lifetime. The third award was Jai Krishna Memorial Award. Professor Jai Krishna was the first president of INAE, and in his memory this award is given every year. And Professor S.N. Mitra Memorial Award. This is an award which, depending on sections given, so as a result, effectively out of the 10 sections, there are 2 awards. Outstanding Teacher Award. yesterday again, we heard Professor Kulkarni on this, and this was honoring engineering teachers who done some amazing work in their lifetime. And this again was two teachers yesterday who spoke and will be awarded today. Woman Engineer of the Award was granted to one lady, and she also spoke yesterday. And of course, along with that, we'll be seeing the INAE Young Engineer Award and of course the Young Innovator and Entrepreneur Awards. So in effect, we'll be seeing multiple awards being granted today. So bear with me without taking any more time. In the interest of time, we have in about an hour's time a major sort of invited talk. Professor Vashi is going to speak on the solar ecosystem in India, and before that we need to be winding up the award ceremony. So I'll not take much of a time so that the awardees have one or two words in acceptance of the award. Thank you so much.
Thank you, sir. Now we will commence the presentation of awards. We will first recognize the exceptional young minds shaping the future of engineering with the INAE Young Engineer Awards 2025. I would request Dr. Diya Prasada Raju, R&D and Advisor, Visiting Professor, IIT Madras, Tirupati PSG Institutions, Coimbatore, GMR Institute of Technology, Geetam, Visakhapatnam, to kindly come on the dais and please read the citation of Young Engineer Awards. Thank you, sir.
Good evening to everybody. It's indeed a great pleasure inviting our young minds to receive the award. The INAE Young Engineer Award is given to given to recognize outstanding achievements, contributions made by young engineers with strong potential for future professional growth impact in any branch of engineering. The criteria for selection is evidence of excellence in engineering research, product, process, design, technology development, and transfer specific contribution submitted for consideration of the award should have been carried out in India. Work should have been carried out in India. Any citizen of India not older than 35 years and any one degree in engineering technology as on 1st January of the year is eligible for consideration. However, lady nominees are eligible for age relaxation of 5 years for the award. The award shall consist of a cash prize of 25,000 and a citation. The subject award was not conferred during the years 2023-24 due to government directives and was reinstituted this year after disengagement and attaining of functional and financial autonomy by the Academy from 1st April 2025 onwards. All INAE Young Engineer awardees will become INAE Young Associate on conferment of award and shall continue to be INAE Young Associates till attaining 45 years of age. Up to 30 awards are to be conferred each year. So 29 nominees have been selected for conferment of INAE Young Award Engineer for the year 2025. So I'll read out the names of these Young Engineer awardees. I would request them to come and receive the award from Honorable President. The first one, Professor B.S. Sindhu, Principal Scientist, CSIR, Structural Engineering Research Center, Chennai. Selected for her outstanding contributions in the area of nano engineering and cementitious and epoxy composites and damage characterization. The second award is Dr. Arya Vidyanathan, Associate Professor, IIT Delhi, selected for outstanding contributions in the area of environmental engineering. The third one is Dr. Ankit Agarwal, Associate Professor, IIT Roorkee, selected for his outstanding contributions in the area of hydroclimatic extremes, teleconnections, and data-driven earth system sciences and dynamics. The fourth one is Dr. Asutosh Kumar from Indian Institute of Technology, Mandi, selected for his outstanding contributions in the area of soil structure interaction, landslides, sensing technique for geotechnical applications. The fifth one is Dr. Chaya Ganesh, Assistant Professor, Indian Institute of Science, Bengaluru, selected for her outstanding contribution in the area of cryptography, security, theoretical computer science. The sixth one is again from IASC, Dr. Sumit Kumar Mandal, Assistant Professor, selected for his outstanding contribution in the area of hardware acceleration of large language models, processing in memory, and edge computing. The seventh award is Dr. Sayak Rai Chowdhury from Indian Institute of Technology, Kanpur, selected for his outstanding contribution in the areas of machine learning, artificial intelligence, and large language models. The next one is Dr. Gurminder Singh from Indian Institute of Technology, Bombay, selected for his outstanding contribution in the areas of additive manufacturing, material science, and finite element analysis. Next is Dr. Venkataran Kiran, Scientific Officer from Nuclear Fuel Complex, Hyderabad, selected for his outstanding contribution in the areas of design, manufacture of special purpose machines, automation, and resistance welding. The next award is Dr. Vicky Anand from IIT Jodhpur, selected for his outstanding contribution in the areas of electrodynamics, water and wastewater treatment, and membrane technology. The next one is Dr. Harshal Agarwal from CSR, Central Electrochemical Research Institute, Chennai, selected for his outstanding contributions in the areas of applied electrochemistry, hydrogen energy, fuel cells, computational fluid dynamics. The next award is Dr. Aniket Uday Toshar, Senior Manager from Reliance Industries, Navi Mumbai, selected for his outstanding contributions in the areas of hydrogen value chain, multi-scale, multi-physics modeling. The next awardee is Dr. Vishnu Mahadev Iyer from IASC Bangalore, selected for his outstanding contributions in the area of power electronics. So thank you so very much.
Thank you, sir. I would now request Dr. T. Bhaskar, FNA, Tata Steel Limited, to kindly come to the dais and please read the citation of remaining young engineer awardees. Thank you, sir.
Thank you. I would like to call upon Dr. Sandeep N., Assistant Professor, Malviya National Institute of Technology, Jaipur. He is selected for his outstanding contributions in the area of power electronics. Next, I would like to call upon Dr. Srinath Vijay Kumar, Associate Professor, Institute of Technology, Palakkad. I think he's not here. Next is Dr. Vikrant Kaim, Assistant Professor, Institute of Technology, Delhi. Dr. Kaim has been selected for his outstanding contributions in the area of electromagnetic theory, implantable, wearable, ingestible medical devices. Next, I would like to call upon Dr. Balaswamy Velpula, Assistant Professor, Indian Institute of Science, Bangalore, selected for his outstanding contributions in the area of low noise fiber lasers and non-linear fiber optics, optical coherence tomography. Next, I would like to call upon Mr. Gaurav Kumar, Scientist Engineer, SC Space Application Center, ISRO, Ahmedabad. He is selected for his outstanding contribution in the area of RF and micro antenna technology. Next, I would like to invite Dr. Sai Gautam Gopalkrishnan, Assistant Professor, Indian Institute of Science, Bangalore, selected for his outstanding contributions in the area of computational material science, material design for energy applications. Next, I would like to invite Mr. Bhad Reddy G, Scientific Officer, E, BARC, Mumbai, selected for his outstanding contributions in the area of thermomechanical processing, structure property correlations, deformation micromechanics. Next, I would like to invite Dr. Prem Kumar Murugayan, Principal Scientist, CSR National Metallurgical Laboratory, Jamshedpur. He is selected for his outstanding contributions in the area of physical metallurgy, bulk magnetic alloys, electromagnetic NDE sensors. Next, I would like to invite Dr. Pallavi Das, Principal Scientist, CSIR, Central Institute of Mining and Fuel Research, Dhanbad. She is selected for her outstanding contributions in the area of novel separation processes, chemical engineering process design, wastewater treatment. Next, I would like to invite Dr. Ranjit Tangavel, Assistant Professor, Indian Institute of Technology, Tirupati, selected for his outstanding contributions in the area of energy storage, batteries and supercapacitors, functional materials, and biomass carbon. Next, I would like to invite Dr. Mohit Kumar Jolly, Associate Professor, Indian Institute of Sciences, Bangalore, selected for his outstanding contributions in the area of computational and mathematical biology, theoretical biophysics, and bioengineering. Next, I would like to invite Mr. Jayantrao Dilip Rao Mohite, Scientist, Tata Consultancy Services, Mumbai. He is selected for his outstanding contributions in the area of geospatial AI, remote sensing, sustainability, and agriculture MRV. Next, I would like to invite Dr. Richa Karmakar, Assistant Professor, Indian Institute of Technology, Madras. She has been selected for her outstanding contributions in the area of microfluids, chemotaxis, cellular biophysics, lab on a chip diagnostics. Yeah, I understand Dr. Srinath Vijay Kumar is here. No, he's not here. Okay, that concludes the Young Engineers Award. Thank you.
Thank you, sir. Following this, we will move on to the next set of awards, the INAE Young Innovator and Entrepreneur Award 2025, honoring individuals who have demonstrating outstanding creativity, entrepreneur spirit, and path-breaking innovation. I would request Professor T. Pradeep, FNAE, IIT Madras, to kindly come on the dais and please read the citation of INAE Young Innovator and Entrepreneur awardees. Thank you, sir.
Good evening. What a great pleasure to be here. The first award goes to Aditya Sadhanala, Assistant Professor and Pratiksha Young Investigator Chair, SENS, Indian Institute of Science, Bengaluru, and co-founder and director, ABX3PV Private Limited, awarded for pioneering contributions to thin film optoelectronics, enabling adaptable perovskite photovoltaic modules for India's diverse rooftops and advanced applications. The second award goes to Dr. Ananya Barui, Assistant Professor, Center for Healthcare Science and Technology, Indian Institute of Engineering, Science and Technology, Shibpur, awarded for significant contributions at the interface of cancer diagnostics, regenerative medicine, and biomedical engineering, and development of an indigenous AI-generated, non-invasive, and label-free screening platform for oral and cervical cancers. The next award goes to Mr. Shiva Gautam Kumar Patapu, founder and CEO, Raxion Private Limited, Hyderabad. Awarded for significant contributions to advanced composite structures, aerospace systems engineering, and indigenous deep tech manufacturing for strategic applications and contributions to structural and systems design in Hyperloop team, placed first in the US and fourth worldwide. That concludes this section of the awards.
Thank you, sir. We will now confer the INAE Women Engineer of the Year Award 2025, celebrating excellence, leadership, and impactful contributions by a distinguished woman engineer. I would request Professor Shivaji Chakravarti, Vice President INAE, to please come and please read the citation of INAE Women Engineer awardees. Thank you, sir.
So presentation of award to INAE Women Engineer of the Year 2025. In the year 2025, the nominee selected for conferment of the award in industry category is Dr. Geeta Manjunath, founder, CEO and CTO of Niramai Health Analytics Private Limited, Bengaluru, who founded a startup that has pioneered a new non-invasive imaging test for detecting early breast cancer. She led her team to develop Thermalytics cancer screening test, which is now clinically proven and regulatory approved in 20+ countries, and is an affordable, accessible, and high-quality cancer screening test. Presentation of award to INAE Outstanding Teacher Awardees 2025. This award is given 2 per year in 2 groups. Group 1 that comprise Engineering Section 1 Civil Engineering, Engineering Section 3 Mechanical Engineering, Engineering Section 4 Chemical Engineering, Engineering Section 7 Aerospace Engineering, and Engineering Section 8 Mining, Metallurgical and Materials Engineering. In the year 2025, the award in Group 1 is conferred upon Professor Shishendu De, Professor of Department of Chemical Engineering, IIT Kharagpur, for outstanding teaching contributions as a well-known teacher for his courses, namely Advanced Mathematical Treatment in Chemical Engineering, Novel Separation Processes, and Transport Phenomena. His NPTEL lectures on these subjects are extremely popular not only in India but also abroad. In group 2, we have engineering section 2, computer engineering and information technology, engineering section 5, electrical engineering, engineering section 6, electronics and communication engineering, engineering section 9, energy engineering, and engineering section 10, interdisciplinary and special engineering fields, and leadership in academia, R&D, and industry. The award in Group 2 in 2025 is conferred upon Professor S.V. Kulkarni, Professor of Department of Electrical Engineering at IIT Bombay, for his outstanding teaching contributions. He was INAE Chair Professor in his department and has more than 25 publications in reputed journals and conferences. He organizes several training programs on transformers and computational electromagnetics and completed many industry projects. Presentation of award to INAE Professor Jai Krishna Memorial Awardee 2025. INAE Professor Jai Krishna Memorial Award for the year 2025 is being conferred on Professor Anil Kumar Bhaumik, former Professor of Eminence at the Indian Institute of Technology, Kharagpur, and founder director of IIT Patna, and currently a faculty at the University of Houston, USA. He is renowned for his outstanding contributions to the development of polymer nanocomposites, sustainable materials, thermoplastic elastomers, and industrial polymer compounds in the materials engineering discipline. Professor Anil Kumar Bhaumik has been conferred INAE Professor Jai Krishna Memorial Award in recognition of his outstanding research contributions in the areas of polymer nanocomposites and sustainable materials and development of rubber products for industry. Professor Bhaumik is presently in the US, so he is unable to come here, but he is in the online mode. He is online. No sound.
Heartfelt thanks and gratitude to INAE, especially the jury members for selecting me for the INAE Professor Joy Krishna Memorial Award 2025. Thank you once again.
Presentation of award to INAE Professor S.N. Mitra Memorial Awardee 2025. INAE Professor S.N. Mitra Memorial Award for the year 2025 is being conferred on Professor Bhim Singh, ANRF National Science Chair and Emeritus Professor, Department of Electrical Engineering, Indian Institute of Technology, Delhi, who is an internationally acclaimed electrical engineer whose pioneering contributions in power electronics, electric mobility, and renewable energy systems have profoundly impacted India's scientific, industrial, and social landscape. Professor Bhim Singh is being conferred the INAE Professor S.N. Mitra Memorial Award in recognition of his outstanding research contributions in electrical engineering and pioneering work in power electronics, electric mobility, and renewable energy systems. Now we have come to the presentation of awards to INAE Lifetime Contribution in Engineering. INAE Lifetime Contribution in Engineering Award 2025 is being conferred to 22 nominees. INAE Lifetime Contribution in Engineering Awards 2025 is conferred upon Professor J.B. Joshi, Chancellor and former Director, Institute of Chemical Technology, Mumbai, a renowned chemical engineer who has done truly outstanding work in developing design procedures for multi-phase reactors which form heart of the chemical process and nuclear industry. He deployed a unique blend of theory, modeling, experiments and intuition which has resulted in a rational basis for the design and scale-up of a large number of commercial-sized reactors in India and throughout the world. Professor J.B. Joshi is conferred the INAE Lifetime Contribution in Engineering Award 2025 in recognition of his outstanding contributions to the growth of the chemical process industry in the country and leadership role as an academician and institution builder. And now to the other Lifetime Contribution in Engineering Award 2025. INAE Lifetime Contribution in Engineering Award 2025 is conferred upon Dr. Shanak Mishra, former President INAE and former President of the Indian Institute of Metals, and former Managing Director, Rourkela Steel Plant and Director, Steel Authority of India Limited, Vice President, ArcelorMittal and CEO, India Projects and Secretary General, Indian Steel Association. Dr. Shanak Mishra is a renowned metallurgist whose life is an inspiring testament to the powerful intersection of science, engineering, technology, industry and transformational leadership. Dr. Shanak Mishra is conferred the INAE Lifetime Contribution in Engineering Award 2025 in recognition of his outstanding contributions in the field of metallurgical engineering and leadership role in the growth of the steel industry in the country.
Thank you, sir. Thank you for being here, confirming the awards. And now we will wait for the next session, which is due in next by about 7 p.m. Yeah. So we have some time on our hands. Thank you. You can take a break. Thank you. Ladies and gentlemen, the speaker for the next session, Professor Vasi, and the session chair would be here soon. Next 5 minutes, may I request to kindly be seated after a short break. Thank you very much. क्या हुआ? Pen drive? दूं? कौन? अभी अच्छे से मैं अनाउंस करूंगा.
Driving progress across sectors from infrastructure to defense, healthcare to digital. But the key question remains, are we preparing our engineers for the future?
ये बंदा कहाँ सो रहा है?
Over 1 million students entering engineering colleges every year across
PDF is safer. Typically, PDF is safer. That's the whole idea, no? It's independent of the document format. That's the whole idea of PDF. Oh, it's not even showing on the screen.
That's a different system, so he'll switch.
It's not switched off, so it doesn't look nice that way. It's not switched off.
Just check it on the screen once. Just check it on the screen once.
You just have to switch once.
Just एक बार देख लो. आ गया. ठीक है. हाँ? क्या हुआ? Can you? But does it move up and down on the screen? Oh, good, good. Okay. Now you can go back to your HA.
That's with the
PPT. Oh, इससे नहीं हो रहा है.
क्यों, इससे क्या प्रॉब्लम है? कंट्रोल एल कर दो उसको.
otherwise
In the
like
morning
you
it
said,
was working fine. I think there were people who made presentations. Ashutosh made the presentation. He was able to go back and forth. क्या हुआ? नहीं जा रहा?
it works, otherwise
We'll call the technician. He's just here.
बैटरी तो नहीं है.
Slightly move कर.
डिस्प्ले नहीं किया. नहीं, this is remote is not working.
ये तो लेजर है. हाँ हाँ हाँ.
केबल निकाल दिया था. लो, the oldest double E. Sounds like a Peter Sellers movie, you know. The cable they disconnected it. He forgot to connect it back.
Alright, so we'll just request you to come on the screen for the after just a Sir, को mic, you'd like to use a collar mic?
yeah.
Color mics. Color mic.
Yeah, then you can move around. It will be easier.
Ready to start?
Ready to start.
You tell us, sir.
Yeah,
Convenient time.
lightning power is
Long press, sir. बोल के देख लो.
Yeah, I think she has.
Alright.
So you want us to call up from there or we just wait here? So you want us to go down, then she will call, then we come. No, no, it's okay. That's the protocol she's been following all day.
long.
Ladies and gentlemen, thank you for being with us for the Grand Award ceremony. Let us now proceed to the plenary talk on commemorating 50 years of solar in India, achievements and challenges by Professor Juzer M. Vasi, FNAE, Professor Emeritus, IIT Bombay. The plenary lecture will be chaired by esteemed Professor U.B. Desai, Vice President INAE and former Director IIT Hyderabad. May I request Professor U.B. Desai, Chairperson of the session, to please come on the dais and also invite esteemed speaker Professor Juzer M. Vasi, FNAE, Professor Emeritus, IIT Bombay on the stage. I am sure the audience would be eager to listen very keenly on this contemporary topic. Thank you, sir.
Good evening, everyone. I wish some of the awardees had stayed back, but I guess they have something better to do. Uh, it's a very unique privilege to introduce Professor Vasi. Professor Vasi has been a friend for now, what, since 87, I guess, you know. I joined IIT Bombay in 87 and I've known him for a very long time. So I'll do a formal introduction and maybe make some personal remarks along the way because, you know, we have known each other for a very long time. So he's Professor Emeritus, as it says out here, in the Department of Electrical Engineering at IIT Bombay. Okay. And he was also the Deputy Director at IIT Bombay. He served as visiting assistant professor at Johns Hopkins University, and I think he was also an assistant professor for a few years at IIT Delhi before so after a PhD at Johns Hopkins in the US, he joined IIT Delhi, and then from IIT Delhi he came to IIT Bombay. Professor Vasi is an eminent academician and researcher who has made seminal research contributions in the areas of solar reliability of solar modules, deployment of solar PV in India, global deployment of solar PV, nanocrystal-based solar cells, and nanoelectronics. In fact, I would say he is the one in India, in fact, I would almost venture to say that, who established a very strong program in microelectronics. If I look at IIT Bombay, the whole microelectronics program was in a sense spearheaded by him. Then he also spearheaded the nanoelectronics program. From what I recall, and of course Professor Vasi can correct me, I think it was Dr. Chidambaram who approached him to start the whole nanoelectronic mission in the country. And the two big centers were established way back, more than 25 years ago, I think. One at Bangalore and of course the big one at IIT Bombay. And then a little later, he started this very huge, big center on photovoltaics also at IIT Bombay, which is currently very active. And I think Professor Vasi is still involved with the photovoltaic shelter and still kind of participating in some of the R&D activities out there. His work, I think the early work when I joined, I remember, I'm not going through the usual thing, one of the pioneering work he did in the country was on radiation hard devices. A lot of chips sometimes which are there in space and in with BRC, and Professor Vasi can say more on that. I think they came because of the work that he did at IIT Bombay. Okay. Professor Vasi is Fellow of Indian National Academy of Engineering, Fellow of IET. Okay. He has many prestigious awards. Okay. One of the things I will tell, IIT Bombay has this Excellence in Teaching Award, and it's very difficult. You get it once in 4 years. We have a very peculiar protocol that if you get once, for the next 3 years you're not eligible. So other people can get it. So Professor Vasi has got it 3 times, 2000, 2009 and 2013. It's very rare, to have it. I think there are very few people in IIT Bombay who get it so many times. Okay. He's got the Mathur Award for Excellence in Research from IIT Bombay, Techno-Visionary Award by Semiconductor Association in 2008, Lifetime Achievement Award from Indian Institute of Technology Bombay, 2013, INAE Lifetime Contribution Award in Engineering in 2018. And if I'm not mistaken, maybe something is missing, you also got some Lifetime Achievement Award from the Semiconductor Society in India. Yeah. So I think, he has several Lifetime Achievement Awards. Most of us cry for one. Well, Professor Vasi is a rare researcher and a rare academician who has multiple Lifetime Achievements Awards, and really, I'm really proud to be his friend. I've learned a lot from him, and it's really as I said, a privilege to introduce him in this particular gathering. So Professor Vasi, the stage is all yours, and we are very anxious to listen to your presentation. Thank you so much.
Thank you. So thank you, Uday. Let's see. Okay, maybe I'll use this. Thank you, Uday, for the introduction. And as he said, we've been together. We were together at IIT for many years before he moved on to IIT Hyderabad. I agree with you. Both the centers of excellence in nanoelectronics, and as you said, for many years I was involved with microelectronics and nanoelectronics. Never thought of really moving to solar energy and photovoltaics. Both of those at IIT Bombay and at the Indian Institute of Science were really an initiative started by Dr. R. Chidambaram, and he really made this happen. And then later he also requested us to start a center for photovoltaics, just as the National Solar Mission was getting underway in 2010. I was a bit reluctant because I had spent many decades earlier working on what I thought of as the cutting edge of semiconductors, micro and nano electronics. But I also felt that both microelectronics and nanoelectronics were too far away from the everyday requirements of India. So when he suggested solar energy, which I could immediately understand is a very important technology for India, I agreed to get on there, and I have never regretted it, because actually solar energy is doing wonderful things, and of course I'm sure you all know about it, and that's what I would like to talk about today. So I'm calling this talk commemorating 50 years of solar PV photovoltaics in India. Just to mention that I'll talk mainly about photovoltaics, because coming from the semiconductor background, that is really where how I see solar energy. But it's also true that almost all the solar energy we are seeing, not only in India but in the world today, is almost all photovoltaics. So we've had really very good achievements over the last 15 years, but also we are planning to move ahead very rapidly, but there are challenges. So I'll talk about both the achievements and the challenges. No, it's okay, no problem. So here's a quick outline of my talk. Because it's 50 years, I thought I must mention something about the history of solar photovoltaics. Of course, you're all familiar with our National Solar Mission, but I'll just give some points so that the achievements and the challenges, and really India is playing a major role in the world in solar, so that will be covered also. So what's the history of solar PV in India? Well, after the oil crisis of 1972, which some of you may remember, India, like many other countries, also we started working on solar energy. And in 1975, India set up the Central Electronics Limited. I was at IIT Delhi at that time, together with Professor Murthy, to deploy and manufacture solar cells and modules. So solar energy is now officially 50 years old. In fact, I'll mention a bit later that the very next year, 1976, CEL started actually manufacturing solar cells and modules. And then various other things happened. For example, in 1982, we set up the Department of Non-Conventional Energy Sources. Today, it's the Ministry of New and Renewable Energy, the very first such ministry of any government focusing on renewable energy. Even today, I think it's probably one of 2 or 3 countries. And the main aim really was to develop solar energy to deploy in rural and remote areas, and also manufacturing solar cells and modules for such applications. So here are some pictures which I found in the literature. Of course, I was very far away from solar energy, but just looking at how things were going. Here are some examples of early deployments of solar PV in India. Firstly, deployment in remote areas. Ladakh is one of them. We visited several of the very early deployments in Ladakh, and you know how the modules were transported, Lakshadweep, etc. Deployment for rural communities. Solar pumping was very important, continues to be even today very important, not only in India but in many other countries as well. Solar community TV, street lighting, and also deployment for technology. For example, here are some examples of that. What did early solar manufacturing in India? So I'm really splitting it up, deployment and manufacturing. In a sense, both of these one has to one has to take together, and I'll talk about here the early manufacturing. And by early I mean starting 75 and going up to about 2010 and or so. And as I mentioned, CEL was one of the first companies, was the first company, but they made their first research solar cells and modules in 76, 77. So again, I'm looking at 75, 76 as the start of solar energy, solar photovoltaics certainly in India, and so we are 50 years from that date. Pilot scale commercial manufacturing started some years later. In 1985, CEL had a good production capacity. Of course, today 1 megawatt per year will not amount to anything at all, but in those years it was quite good. Here's an example of one of the early CEL modules, a rating of 33 watts. And we'll compare that to some of the recent modules. Soon after, two companies, two other places, one was Tata BP Solar. Tata tied up with BP Solar. Also BHEL started manufacturing and deploying in the late 80s. Tata BP Solar, by the way, you know, they exported a lot of their solar modules all over the world, really one of the early countries in India, or for that matter anywhere in the world. Just for example, I'll just mention that Tata BP Solar was involved in setting up rooftop plants in Beijing in China. And this was of course in the 80s, and of course the situation has completely reversed today, but we must, hopefully there are signs that we are going to come back to our earlier, not leading position, but at least a good position. By the 2000s, there were several other companies, Mozabeer, Wari, Vikram, etc., who were manufacturing solar modules and also solar cells. I'll just go into that a little bit later, for both domestic and export markets. That's important to remember because in the early 2000s, Europe had started setting up a lot of solar, Germany and various other countries, and some of these, our Indian companies were actually exporting there. But after the mid 2010s, all these manufacturers actually face stiff competition from Chinese imports. Not just, you know, low-cost Chinese things. These were very high-quality Chinese modules coming in. Was difficult to compete. However, what I would like to say, and that's why I put it in red here, the experience which we had from those years really has stood us in good stead all these years, and now we're seeing a resurgence of manufacturing, which I'll touch upon later. Here are some of the modules. For example, look at this module, very interesting module. Huge modules made by Mozabeer. Unfortunately, they were using a technology of amorphous silicon, which it turned out could never achieve good efficiencies, and therefore that technology fell by the wayside. I don't really want to go into the basics of solar photovoltaics, which would of course be not only a full lecture but even a full course by itself. But it's actually an amazingly simple device. You shine light on silicon. The silicon junction, PN junction, converts that energy into electrons and holes which can be separated out, and if separated out they flow in the external circuit and produce a current. So you're really transforming the sunlight's energy, photon energy, into electrical energy. Here is what the typical solar panel looks like. Silicon, of course, is at the heart of the module, but then it has to be well encapsulated, well packaged, and put together, and that's what it looks like. Here is the glass surface, here are the silicon cells, nicely packaged, put all together, and therefore there are really two aspects of the manufacturing. The more technically difficult part is manufacturing the solar cells to have sufficient efficiency, but also we must worry about the packaging part. Packaging often does not get the same due as the cell itself, but the packaging is important, and one reason it's important is that the module has to stay out there in the field in harsh environments for 25 years. So unless it's well packaged, it may not do that. So a state-of-the-art module today, you remember the old 33 watt, but this now generates about 650 to 700 watts per module, and efficiencies are much higher, about 24% or so. Incidentally, we are close to the so-called Shockley quasar limit, which is about 28%. So there's not much room to increase further. And how do we get to higher efficiencies? I'll just mention that a bit later. So our National Solar Mission, as you probably know, was launched in 2010 and had at that time what seemed to be a very ambitious target of 22 gigawatts by 2022. But this was then in 2015 increased to 100 gigawatts by 2022. And this was possible because really the price of solar started decreasing sufficiently that it seemed quite possible for us to go up to 100 gigawatts. Utility scale and rooftop, we'll touch upon that a bit later. So by the end of 2022, we had achieved 63 gigawatts instead of 100. But I think that was really quite creditable because 53 gigawatts really came from utility scale. Rooftops we could not do as well, and there are various reasons for that. Of course, our next step came in 2021 when at COP26, the Prime Minister announced that we would have 500 gigawatts of what we call now non-fossil fuel electricity by 2030. In other words, about 300 gigawatts of solar by 2030. India's COP26 commitment actually said that 50%, the 500 gigawatts, meant that 50% of our capacity should come from non-fossil fuels by 2030. Let's just see what it is today. As of today, our total electricity installed capacity is 505 gigawatts. And actually 259 gigawatts of this come from non-fossil fuel sources. Solar is a major component of that. So really our commitment of 50% from non-fossil fuels by 2030, today we are at 51%. And if we keep going at this rate, we will certainly come to 50%. We will certainly exceed 50% by 2030. I'll just show that in some detail in the next slide. So for example, in the first 10 months of this year, we added somewhere around 43 gigawatts total capacity. Only 1.1 gigawatt of that was thermal, 41.2% was renewables. Large part of it was actually solar. Also interestingly, for the first half of 2025, we saw 1% decline in the carbon dioxide emissions from the electricity sector, only from the electricity sector. The first time ever, except during COVID, of course, we had seen a dip. But I must admit that part of this decline was the fact that the summer of 2025 was an unusually cool summer, and therefore the AC usage was not that much. But still, it's a very nice point to remember that we can get to declining carbon dioxide emissions by really transitioning from thermal electricity to solar. Here's the same thing in a pie chart. Here is the first thing is the capacity breakup. That's the total capacity. The capacity as of October 31st, the latest data as I have from the CEA. So today, 26% of our electricity capacity is solar. So that's a very large number coming from literally 0% in 2010. So we've made enormous strides in the last 15 years. And if you look at the additions of during this year, 75% of the additional capacity we have put in 2025, 76% of that has come from solar. So if we go on this path, there's no doubt at all we will reach that 50% commitment by 2030. In fact, we'll far exceed 50%. Incidentally, India is one of the few countries where what we committed at COP26, we are on target to meet. Unfortunately, that's not true of many of the other countries, including some of the big ones. So India, again, starting from literally zero in 2010, we are now the third largest country, both for the annual installed capacity as well as the cumulative capacity. So we've done very well. And if you really look at the solar deployment, again, data from CEA, you can see it's really increasing very rapidly, exponentially, and we've really been looking at this, and there's no doubt in my mind that India was able to achieve this very rapid growth in deployment really because we had the expertise going back to the mid and late 70s. In other words, the 50 years of experience which we have. Here are the predictions of global solar capacity going up to about 2060 or so. So just look at these numbers. Of course, the 1 terawatt was a landmark which people were talking about for years, which we crossed in 2022, late 2022. We crossed 2 terawatts in 24. We'll cross 3 terawatts in another couple of months. And we are predicted to reach 75 terawatts of solar capacity by 2050. In other words, what's happening is really a global transition away from thermal and gas, oil, coal, towards wind and solar is actually much more than even wind. And the simple reason is that it is actually today the cheapest source of electricity. Besides, of course, being a clean energy and so on. And the reason for this is the so-called PV learning curve. By the way, this is something which the PV people got from the semiconductor people, where they also talk about the Moore's law and the learning curve. And that is, how does the cost of a particular item, in this case a solar module, decrease not with time so much as with the capacity. The more you make, the more you deploy, the cost comes down, and you can see it's a very dramatic decrease. It's gone down from initially hundreds of dollars per watt in the very early years, going down to about 10 cents today. So 10 cents per watt. I'm talking about cents only because it's a global commodity really. And it's been decreasing very rapidly, and as I said, as a consequence of that, really, as I say here, solar PV is already already the cheapest source of electricity on a levelized cost of electricity basis. So today it makes sense to put up solar rather than any other type of electricity unit. Let's look at some of the deployments which we've had. Well, utility scale versus rooftop. Actually, even as of today, of the 132 gigawatts of solar which we have, ground-mounted solar is only a ground-mounted solar. Large utility scale power plants like the one shown in this place or in both these two very large solar parks, gigawatts, 2 gigawatts each. Most of it comes from these large utility scale power plants. Rooftops is relatively small, and that's something we need to see whether we can increase the rooftops or not. The rooftop deployments, as I say, are still lagging. Of course, we have the new scheme, but even then the rooftop is not taking off very quickly. And the main reason really is a low consumer awareness. It's very fragmented. You can set up few kilowatts of solar on a rooftop, whereas a single solar park can have gigawatts. So, but there is a need to go to rooftops, and I'll tell you the reason why. Okay, we'll come to that a bit later. Let me just talk a little bit about the manufacturing. So deployment is very good. And of course, we've been deploying a lot of solar, but almost all of this solar, both the cells and the modules, are coming in from China. So that's something we need to worry about. In mid 2022, India had about 5 gigawatts per year of cell and about 25 gigawatts per year of module manufacturing capacity, all silicon based. Now this is a fairly complex process. You have to start with polysilicon, go to wafers, make solar cells, and then PV modules. China today manufactures about 95% of the ingots, wafers, and cells worldwide. So the whole world is dependent on China for getting this. And modules, 85%, because modules basically packaging, and it's being done at several places, including in India. But to ensure energy security and to avoid supply chain disruptions, India really took an initiative about 2021 to come up with some incentives to make solar, to do manufacturing in India. So here are some of the incentives. One is, of course, the performance-linked incentive in 2021 that has put in giving incentive for manufacturing, impose basic customs duty on importing cells so as to, if you'd like, protect the Indian industry. The so-called approved list of models and manufacturers, which is, they have an approved list for any government project, only modules made or which are classified under this approved list, which by the way has only Indian manufacturers, will be allowed. There's also a domestic content requirement, and most recently an anti-dumping duty has also been imposed. So there are many incentives to manufacture in India, but also, as you can see, many disincentives to import from elsewhere. Is that good or bad? Let's look at it later. So if we look at the year-wise solar manufacturing capacity in India, as I mentioned, in 2022, our module capacity was about 25 gigawatts per year. So this is the way they count the capacity, gigawatts. How many gigawatts can you manufacture in a year? Our cell capacity was about 5 gigawatts, so much more complex and also a much more expensive technology to set up. But after the incentives were announced, as of today, you can see that we now have 121 gigawatts of module capacity and about 18 or 19 now gigawatts of cell capacity. But actually a lot more of this is in process, and by 2028 these are the numbers we will have, and by 2030 we will have these numbers. How much do we need in India? The answer is we need only about 30 to 40 gigawatts of solar, because that's our plan to reach the 300 gigawatts by 2030. So what happens to the rest of that excess capacity? Well, we think and we hope that we will emerge as a major exporter of solar over the next few years. In fact, in 2023 and 24, exports from India to USA really went to very high levels. I'll show you that in another slide later. But for reasons which we all know, this will definitely declining in 2025. Again, I want to just mention that the rapid growth of solar manufacturing, also, there's a lot of latent and real availability of expertise and manpower, really going back to the early years, so we could really ramp up our manufacturing very rapidly. So that's the status as of today, and a little bit about what it will look like in the future. Let's look at some of the challenges. I'll first look at challenges for solar deployment. One problem definitely is the availability of land. Especially for very large solar parks, you need to acquire hundreds of acres, thousands of acres of land, and that is not easy to get. You can see I've just mentioned here, a lot of our land is under agriculture and so on. So how to get these very large areas of land, that's a problem. Well, one way to get over this is actually go on rooftops. But then you're faced with the problem of trying to get to large numbers of capacity with very small individual deployments. But another way is to look at floating solar, which is shown up here. The floating solar, we do have large tracts of lakes, water, where we can have floating solar. More complex and technology, etc., but that's a possibility. Another is agrivoltaics, dual use of land for both agriculture as well as energy. These are two things which we have to look at. Just mentioned here that a recent MNRE report identifies about 3,000 gigawatts of solar on suitable wastelands. That's a problem, that's a possibility. The high altitude plateau of Ladakh, actually very high irradiance, very suitable for solar. But the problem, of course, is that we have to get the grid. Professor Murthy, you would be aware of some of these problems much better than I am, because now how to do all of that is an issue. We'll look at, of course, we are laying the Ladakh to northern grid connection, but it has difficulties because of terrain and other such issues. And also furthermore, we have to enhance our transmission line capability. See, it's very easy to put up a solar park. I almost call it a plug and play technology. Even a 1 gigawatt plant can be set up in a few months. But to lay transmission lines to evacuate that power is a much more long-term, takes much longer time. Also, right of way of land and all of these things you have to worry about. And now we are starting to see severe curtailment of solar. That means, although we are generating a lot of solar, it is being curtailed because there is no transmission line capability to actually evacuate all of it. Other countries are also seeing it. We are also starting to see it. So this is going to be one of our challenges coming up. The other challenge, of course, is there are some environmental issues, and there's something called the GIB issue. The solar people are familiar with this GIB issue, and GIB stands for the Great Indian Bustard, an endangered species. And the Supreme Court mandated that you have to put all these lines underground so that the endangered species don't get affected by these transmission lines. This has been partially relaxed recently, but it actually halted our Rajasthan and Gujarat deployments for some time. And recently, even the HVDC lines in Ladakh are affecting the Pashmina grazing. So this is also has to be considered. So these environmental issues are there. The other big problem, I showed you, of course, some time ago, the capacity looks like this. It looks very good. 26% is solar. Thermal, you can see today, has shrunk below 50%. But that's a capacity. If you look at generation, how much electricity, how much actual generation of kilowatt hours is coming from which source, you can see that thermal is still 70%. So we still get 70% of our electricity actually from coal and a little bit of gas and oil. Solar is only 9%. The reason, of course, is obvious. Although we have huge capacities, but solar and wind are both intermittent. They don't work 24 hours a day, and therefore the actual electricity generation is less. How do we solve this problem? Answer, of course, is can we store the solar? You generate solar during the day and store it. So that is becoming a major challenge, because obviously how do you store it? Well, batteries is one. Batteries are expensive, but the costs are coming down, and actually that's something we need to do. Incidentally, besides batteries, we can also have this pumped hydro, essentially pump the water up to an upper level reservoir during the day and then pull it down, let it flow down like a hydro at night. So all of this is starting to happen, and India is seeing a lot more of it. And this is becoming important for us because, as long as our solar generation was low, it didn't really matter. But as we now go to higher and higher, 25 and more soon, we will have to think about good storage opportunities as well. In fact, now many tenders really call for solar plus storage. In fact, CE has issued an advisory that every solar should now have a minimum of 2-hour storage co-located, that means located right there. There are also, by the way, standalone, BESS is the battery storage source system. You could have a standalone one also, but then you have to send the power, the energy to the BS, so it's much better if it is co-located. So storage is going to be a major challenge in the years coming up for solar to continue growing. Another challenge which we see is the long-term reliability. These panels are supposed to last for 25 years, but the 25-year number really has come from the kind of the kind of certifications which were given in Europe in the early 2000s. And actually those conditions don't apply here at all, because we are much more, temperatures are higher, we have higher humidities, and actually the panels degrade faster. At NCPRE, at IIT Bombay, we had these what we call the All India surveys, where we went around the country looking at modules in different places, and we saw that the modules in hot climates are degrading actually faster, almost twice as fast as the modules in other climates, the so-called non-hot climates. So one interesting thing is that because we recognize this, and we work now with the international community to come up with the new standard for hot climates. So that's something really which we could do only because we saw the problem, and which was really relevant only for our climates. Well, not only for our climates, but as I mentioned here, many other tropical countries also. So this can be a challenge, and we do know how to overcome some of these challenges. So these are the challenges for deployment. What are the challenges for solar manufacturing in India in the coming years? One is the cell technology itself, And the cell technologies are actually developing very rapidly, and unless we do continuous R&D, we will certainly fall behind. I'll just mention here, for example, that out of the capacity of 18 gigawatts which we have today in India, cell manufacturing capacity, actually 11 gigawatts is PERC. PERC is now, was a state-of-the-art technology 3 years ago. Today, it's been overtaken by TOPCon and AGIT. So things are developing that quickly, so that actually a lot of our capacity coming up, or which is already there, is actually already outdated. We need to make sure that as we move forward, our capacities continue to be state-of-the-art. So continuous R&D is required for cell technologies. So we need to do it ourselves, because China, and yes, only China really is forging ahead. There's no other country in the world which is doing the kind of R&D which China is doing. Well, Germany is there, but India must do that. So I just put this picture here to show you that technologies are continually evolving, and we need to be able to do that. And here is now the possible answer to the Shockley quasar limit of about 28%. We can do perovskite silicon tandem cells. Use the silicon plus put perovskite on top, and that can give you efficiencies actually going up to about 40%. People have already shown about 35%. So that is a way forward, which is good for India, by the way, because we do have land constraints. If we can improve the efficiency, we need less land to generate the same amount of electricity. This is an area of active research also, so we have to be involved in all of this research. So that is a challenge for the manufacturing. I would say another challenge is capacity and export possibility. Are we going to have an overcapacity? Because from the numbers I showed a few slides ago, it looks like we're going to have capacities much more than what we need. And we'll suffer from an overcapacity problem unless we can really export most of these, and we can export them only if our technologies are state of the art. So we have to ensure that this happens, and therefore really the R&D is important. Do we have a good export potential? The answer is yes. And I just a chart here where many of the manufacturers actually have been exporting a lot of their production. They prefer to actually export. See, here's the strange situation, and that is India put in these incentives to manufacture in India for our domestic need. So some manufacturers have come up, they're making nice modules and cells. What are they doing to these modules? They're exporting it to the USA because they get a much better price there, and it's worth for them to import cells and modules from China, because actually it turns out to be, even today, cheaper after all the customs duty and so on. So all of these problems have to be tackled, and that is a challenge which we have to look at. And of course, we do know that in 2025, export to USA has almost completely stopped because of the 50% tariff. And let's see what happens later. Another challenge is the cost of manufacturing in India. See, right now we're able to survive because of the customs duty and the anti-dumping duty, but this cannot go on forever. But our analysis, and here's an independent analysis from other sources, is that we can be quite competitive with China and Southeast Asia. Southeast Asia, of course, means Thailand and Cambodia and Vietnam and so on, but all of these are actually Chinese companies operating in these countries. India can be pretty competitive and certainly much better than US and Europe. So there is a very good possibility that we can emerge as a major manufacturing and exporting company, exporting solar country. India and the world in solar. So as I said, India will soon be the second or third largest global deployer of solar energy. China is number one and way above everybody else. US is today number two, but we can probably get there. So what is happening, and this is what we must look at, the economics and protocols for solar deployment globally will be influenced by India. For example, the certification for hot climates, which was really initiated in a sense by India, and other such things, we have to now believe that the protocols for solar worldwide, globally, really we can play and we must play an important role in that. We hope that we will soon emerge as the second largest manufacturer and exporter of solar cells and modules. In fact, this is one very interesting thing. As I go to conferences, people from the world over are interested in what's happening in India, because they see India as a second source for solar components. Really, the world is looking for diversification of the global supply chain. Nobody wants 95% to be made in one country. By the way, India is the co-founder of the International Solar Alliance, and that's where we are playing a major role in interacting with many other countries. And our experience in solar, I believe, will be useful for many countries in the tropical countries and the global south, and we must take advantage of that. So to conclude, well, first of all, of course, 2025 and 26, we will be celebrating 50 years of solar energy in India. As I said, we have really come a long way, and we're one of the leading solar countries, and we must take advantage of this. COP26 commitments we will certainly meet, but we must plan to go way beyond that. Challenges do remain, but these are, I feel, eminently solvable, but we must tackle those. What we learn here is relevant to other countries. And as I say, in the coming decade, we will emerge as really a major solar country. And all our years of experience so far did not go to waste. Really, it has resulted in the deployment as well as manufacturing at a very rapid pace. And finally, to acknowledge, of course, my colleagues from the National Center for Photovoltaic Research and Education. One of our visiting professors, Dr. Rajiv Arya, who was the CEO of Moser Bayer, but a lot of experience in the solar industry all over the world. Also, the MNRE has funded NCPRE continuously since 2010, and that has provided the impetus for a lot of our work. So with these few points, I'll close, but if there are some questions, I'll be happy to talk about it.
I think we have enough time. We can take a few questions. Go ahead. Yeah. Please.
Excellent talk and information. Can you throw some light on concentrated solar for photovoltaic, number one, and reduction of the degradation rate through heat removal?
Yeah, thank you. Both of these are interesting points. And when you talk about concentrating, but you're talking about photovoltaics, concentrating for photovoltaic. So that is certainly possible, and people, of course, have tried it. And we do know that for many applications, this works well. However, I would say that for large-scale terrestrial applications, it will probably not be a good idea, because then you have to worry a lot about removal, because the things get very hot. So removal and the extra cost of putting in the concentrator. Essentially, the question is, can we put some kind of a lens on tops to concentrate the sunlight? So instead of one sun, you're operating at 5 suns or higher, so that because of the extra light coming in, you can actually get more output? The answer is yes, you can, but it comes at a cost. So I don't think for widespread solar deployment it can be very important. On your second point, and that is the reliability is one reason which I gave is the fact that the modules actually operate at a high temperature in India. For example, if the ambient temperature is about 45 to 50 degrees, which is true in many parts of Rajasthan and Gujarat, the actual module operating temperature can go up to 80, 90 degrees. And if it's on a rooftop with very little ventilation, it can go up to 100 and above. Can we hope to improve this by carrying away some of the heat through some means? And actually this is a good idea because the heat doesn't get wasted. For example, if you have water which is cooling the module, you can carry away that hot water and use it for some other purpose. So it is certainly possible. I would say that we should explore this also quite seriously. As of today, from what I know, the problem really is, does it become economically worthwhile to do it? You're putting in the extra money, and therefore how feasible it is. But it is a good idea which we should explore.
It was an excellent talk and very informative. Few issues. One is rooftop. Is a very good.
Can you just hold it closer to your little closer?
Yeah. One is issue is about to encourage the rooftop. Of course, there are consumer resistance and things are there. I feel that is also promising because, as you told, that if you have a distance large gap, then transmission line issues are there. Here in rooftop, such issues are minimal, and you can even think of a decentralized systems where most of the people can have their own required electricity, and which will reduce the considerable load on the grid. This is one issue. I thought this can be encouraged. Number two is because you have dealt with the manufacturing issues, and I think India must give a push on the manufacturing. Otherwise, it is mostly we are importing from China many of the solar systems. Another issue is about converter technologies are equally important. I think that also requires a lot of R&D efforts and these things. Fourth is maintenance of these large ones. I think maybe there will be dust coming. Maybe you require a cleaning. Drones may be used and things like that. I mean, these are a few thoughts I had. Maybe you can react to this if you feel.
Yeah, thank you, Professor Murthy. Actually, all of these points are very important and quite valid. The first point is, since you're worried about transmission line and you're worried about land availability, why not really push rooftops to an extent where a lot of the power, a lot of the energy generated is used at the very place that it is being generated. Of course, today many rooftops connect back to the grid, but you need to only push back some of the generated power to the grid. You can use most of it locally, in which case you don't have to worry about the transmission line problem also. So that's certainly true, and that has been the idea why the government has been trying to push rooftops, and let us hope that there will be some success for that. The second point which you raised is the inverter. Yeah, I did not talk about that at all, but that's a serious issue also, because of course solar generates the power which it generates is DC, and to connect it to the grid you need obviously a good inverter to connect it to the grid, and this is something which we should also look at. Today a lot of these large inverters for the large power plants are all actually multinational companies. This is something which we can definitely look at. Again, look seriously at, I've been told that the derating of inverters because again of our high temperatures is very significant. So we have to look at that also. The third point which you mentioned was the maintenance. And solar energy is claimed to be a zero maintenance thing, because once you have put the solar modules, you don't need to worry about it. It will keep generating electricity for the next 25 years. But that's not quite true, because as you said, one of the problems which we have, especially in India, is actually the fact that dust accumulates on the solar panels and the power declines. For example, in parts of, even in Mumbai, where it's not very dusty, we've seen power declining by somewhere around 10% every month. So if you don't clean your panels every month, your power has gone down by 10%. And in places where it's much more dusty, and Rajasthan is an example of that, it will be even faster. So unless you have very good methods of cleaning the modules, and cleaning a module sounds very easy, but don't forget that you're talking about a gigawatt power plant where they have millions of modules. So unless it's all automated, it's not easy to get it clean. But it is a very serious problem in parts of India, which of course, see, the Europeans aren't worried about it because they don't have that much dust accumulation. We have to worry about it. Which we are, by the way. I didn't touch upon some of the work we are doing on automated cleaning of modules.
Congratulations on an excellent presentation. I'm going to address you as a consumer. I mean, I'm one of the earliest installer of a rooftop solar in Bangalore. I have 11 years of experience with that. I thought I can share some information with you.
Yes, please.
Number one is, overall the picture is very positive. In 11 years, the degradation and so on is not really troubling me too much. But one thing which is really troubling me, which I think you could carry, the way the grid is connected, it needs to be disconnected every time the grid fails, right? Because of and that is a pity. That exactly when I need the power and my solar is capable of generating power, it must mandatorily switch off. Now this is a somewhat idiotic requirement. I'm sure you're aware of this. I've been trying to get this thing changed. It's a configuration change. It's a safety requirement because for some linemen working and so on. But I think that has to change. And I found at least in my neighborhood, most people don't want to install this because it'll have to be switched off automatically. That is number one. The second thing is that absolutely the panel manufacturers do not supply kits for cleaning. It looks like a trivial problem. Even at a rooftop level, 5 kilowatt level, you still need efficient, because it stretches some 3 meters across. So there has to be some kind of a very simple, low-cost tools which can sort of telescopically. I rigged up something. I went around, got some telescopic cleaners and so on. This is not sold at all. I don't see this. These are small things which are, I think, holding back the proliferation of the rooftop for this one. Other is what you mentioned, the degradation of the module itself. I did a little bit of evaluation of my own rooftop system. It looks like that it is mainly from the tracks. The tracks corrosion, not so much the silicon cracking or the efficiency falling through that. At the moment, I find that my estimation is in 11 years probably I have lost about 5% annual output. If I take through the monsoon, I average the whole thing, I probably lost about 5 to 8% of irretrievably. This won't come back. So these are my observations. Whatever you would like to explain.
I'll come to your last point first, because I know the answer to that better than for the other parts. So 5% in 11 years is really quite good, because it means you're losing about 0.5% per year. these modules are supposed to degrade at about 0.5% per year, although the new generation they claim to do about 0.25 to 0.3% per year. But still 0.5% per year is very good, because in many of the climates, at least in many of the modules in the hot climates, we have seen somewhere around 1% or even higher per year. The other thing is, as you mentioned, it's the tracks which seem to, at least visually, be the problem, and that is quite correct, because what you're probably seeing, and since it's Bangalore where the temperatures don't go that high, but the humidity can be high, so it's actually a corrosion which is happening on the tracks, and it's a humidity problem. So it's humidity coming in through the what should be a perfectly well sealed module. But again, even that corrosion is elevated by higher temperatures. On the other two issues which you mentioned, one of them was the availability of, can you do installation by yourself? In other words, have a kit which you can get. Well, the answer is, if you want to do it for a standalone system, it should be possible, not connected to the grid. If it's connected to the grid, then of course you need a licensed electrician, etc. But for the other thing, as far as I know, in India we do not have standalone kits available easily, but I am not very sure about it. The first point which you mentioned, of course, is because of, as you said, the safety, etc. When there is a power failure, your thing also must shut off, because otherwise you would be feeding power to the line, and a lineman working somewhere may get affected. But I think those problems can be solved, because you have to have.
They can be solved.
Yes.
They're not being solved.
No, I think.
7 years.
Yes.
Talking to Bescom and trying to give them other configurations.
Yes.
By which the safety is assured.
Yeah.
But they insist on cutting it off at the generator point.
Yeah, I think they are not.
Double cut off.
Yes. It's. Yeah, so essentially your solar system has to be safely islanded away from the grid. But I guess they are not sure whether it will happen effectively or not. So for them, the easiest solution is make sure that it's cut off.
Yeah, that's true. It should be cut off. I agree. But there are ways of cutting off.
I think.
Yeah, I think.
Yes, I mean cut
we can
off
take
from the
a
grid.
question from Professor Manna. I think he has been asking.
Okay, sorry, Professor Manna.
Sir, I have one question.
Just one sec, I'll come to you. Okay. Let Professor Manna. You go ahead. Yeah.
Just a quick.
Closer to your. Closer.
I wanted to be enlightened about two issues. Number one, manufacturing of silicon. Where are we in terms of not the panel but the silicon, solar grade silicon manufacturing and deposition, creating all those modules. And number two is the waste and recycling part. What is the country's policy and what are we planning to do? 15 years or anything between 12 to 15 years, and then we soon after another 20-30 years will accumulate, imagining what is our target, COP26 target, 50% more than that produced by solar. So what will happen to those waste solar panels? Can we extract again, recycle that solar grade silicon and reuse, or what is the policy?
Yes. So both of these are again, burning problems of solar. On the first point, in the whole silicon chain, as I mentioned, first you have to have the pure polysilicon, which is then made into ingots and cut into wafers. The wafers are then processed and made into cells, which then get put together for the modules. So for the modules and cells, we are pretty okay. We will certainly be okay in about 2 years' time. On the wafers, ingots and wafers, it's a big problem, because China today has 98% of the capacity for making wafers for solar. And we've already, or rather our cell manufacturers are already seeing a problem That is, they are not able to buy the wafers for making the solar cells. So the government has recently introduced a scheme for making the cells and making the ingots. Once you get the ingots, the wafering is not very difficult, but getting the ingots is a very critical issue, and we must put a lot of attention on that. Today, fortunately, the polysilicon, the raw polysilicon from which the ingots are made, that is fairly available from other parts of the world also. So, but that's difficult also, and I mean China is leaping ahead, galloping ahead in.
Professor Vasi, you know
Yes.
more than anyone else how difficult it is to produce those 6-9 or whatever
Yes.
purity we aim at, and that too single crystal and without any misorientation. I mean, you're talking about polysilicon, of course, that's much easier.
Yes. So polysilicon, a big problem is, and to some extent, lesser extent, the ingots and wafer. The cost of it, it is a highly energy intensive project activity which you are well aware of, and therefore for India it has, simply because of the cost of electricity, it is not competitive. But eventually this is something we must get into, because China is obviously capturing the polysilicon market also. So we will at some point not be able to get the polysilicon. But then talking about that, what about the equipment which makes all these things? China now has also, a virtual monopoly on the equipment. So at some point, in fact, we have seen this recently. We are not, cell manufacturers and module manufacturers are not able to get equipment from China because they cite various reasons, and some of them I'm sure are quite valid. So at some point, if you want to do the whole value chain, you have no option but to even do the equipment in India. And on the reuse and recycling, yes, so I think that's quite important. One is reuse, and that is even after the end of life. Many of the modules are actually performing reasonably well and can be reused if you can certify at least that they are safe. You don't mind if they're giving less power, but they must be safe to use. But that's, how do you again certify millions, hundreds of millions of modules to be reused? Recycling is possible, and today the only what shall I say, valuable component others is the silver. And the good news and the bad news is that there's an attempt obviously to reduce the amount of silver, because silver prices have gone up, and in fact they're predicting that by 2035 or so, about 95% of the silver being mined will be used in solar panels. But since the amount of silver you're using is reducing, it is not easy to get value from recycling, but it has to be mandated, and that's what, of course, many governments, including our government, is working on. The only thing I do remember from a presentation made by one of the leading solar scientists from the US, what she said is that even in 2035 or 2040, when we will have a lot of solar waste, it will be about 1% of the municipal waste of that country. So we should worry also about the municipal waste.
Question at the back here.
Hello, sir. So my question is same like sir, only about e-waste. And one more time, why China is monopoly in producing those silicons, sir? Why we can't have any sources, sir?
So, I would say they've just done a, very good job. We know their manufacturing industry is very good. And also what is perhaps not known very well is that they started solar in earnest in about 2000 or so. And they had a 20-year plan for it. So by 2010, 2012, 2015, they really started putting out a lot of solar. So A, we need long-term plans. B, we need a good amount of money. Of course, we need good engineers and scientists, but that I think is not a constraint for us.
Good evening, sir.
Yes. Yeah, please.
Yeah, good evening, sir. Like long-term plan, like I see all gadgets, whether it is mobile phone, laptop, TV, what are even e-cars, like brushless, that LED bulb, everything is going towards DC. Like solar is already giving DC. We converted DC to AC, AC to DC again. Actually, a lot of it is lost actually. The long-term plan, somewhere I think it might be, definitely I think it will be efficient, and including data centers where we have UPS, which is again battery actually. So directly charging DC, and then some gadget will keep, which will connect to the grid also. At the same time, it will do this part, and households going on DC. So what do you want to say?
No, this is very interesting, and that is, you know, much of our usage is now DC. So instead of converting solar, which is DC, convert it to AC using inverters, and then when it comes back from the grid to your home, convert it back to DC. Why not avoid all of that and just use DC locally? So that is certainly possible. In fact, I should mention that Professor Junjunwala at IIT Madras has really gone quite far in this direction. So it is possible. Of course, you don't want to transmit DC over very long distances, at least unless it's HVDC, which again will require its own converters. But for local consumption, it is certainly possible to imagine, for example, a home or even a commercial complex or a mall generating DC through solar and using it internally for whatever air conditioning and other uses by just using DC. So that is certainly possible, but it does mean that you have to really change a lot of things. In other words, the availability of DC driven appliances and so on has to increase and be as cheap or cheaper, which is possible, than the AC. But it is a good idea and we should do it. In fact, as you might know, the prevalence of DC now instead of AC, they're calling it, what are they calling it? Edison's revenge. Because Edison lost out 100 and something years ago, but now it's DC which is ruling.
In continuation with the DC thing, one of the low-hanging usage, especially in urban rooftop, is water pumping. Especially in the high rises, a significant amount of energy is spent in the water pumping. So is there any effort of connecting the rooftop solars for exclusively DC water pumping activity? That is one. Second question is that in 70s we used to hear that the energy spent in manufacturing a PV cell is more than what the PV cell produces. What is the ratio today with 25 years life?
Yeah. So on the first point, this is very interesting. Urban water pumping, which actually I have never thought of. As far as I know, nobody is doing it, but it's certainly a possibility, because we certainly know that rural water pumping using solar and using DC pumps is really the way to go. And it's happening in India, but also happening across the world, especially in the global south. So this urban water pumping, I think this is very interesting. One should look at it. The other point, of course, is the payback period, energy payback. So it's very, very good today. The energy payback is, I think, about 1 year or thereabouts. The cost payback is even less than that. The energy payback is somewhere between 1 to 2 years. And the reason is, of course, twofold. Firstly, the modules have become a lot more efficient, so they're generating more power. And secondly, some of the processes making the solar cells they're using less energy.
And to Professor Vasi, very informative, enlightening talk. Thank you so much. It's really appreciated. And I must thank also the audience for staying back, and being so proactive and asking all these questions. Thank you so much.
And I'd also like to say thank you because a lot of the questions were, very interesting and very illuminating, and I could also learn quite a bit from the questions. Thank you.
Thank you very much, sir, for the insightful and engaging talk. May I now request Professor U.B. Desai, Chairperson of the session, to kindly give a memento to Professor Juzer M. Vasi, esteemed speaker of the session. Let us give another round of applause, please. May I request President INAE, Mr. J.D. Patil, to please come on the stage. Thank you. We now request all the guests to kindly proceed to the dinner venue. Dinner has been arranged at the dining hall. We invite you to join us for evening of delightful conversations over delectable meal. You are requested to kindly note the schedule for day 3 of INAE Annual Convention 2025. We will begin the day with the induction ceremony of newly selected INAE Young Associates 2025 from 9 a.m. followed by annual general meeting of fellows and SGM of fellows to be attended by INAE fellows and young associates. After AGM, there's a fireside chat with Mr. Narayan Murthy, FNAE founder of Infosys. We will have induction ceremony of newly elected fellows and foreign fellows after that. All the dignitaries are requested to assemble the auditorium tomorrow by 8:45 a.m. The detailed program of day 3 is displayed on the screen. Thank you and have a wonderful evening.